This video is going to be modeling data, and before we begin, what does the B and the M represent in the following equation? Y equals mx plus b. Pause the video and see if you can get it. Well, the M stands for the slope in a slope-intercept equation. It's the rise over the run, which most students are familiar with. And B is called the y-intercept. It's where the line intercepts the y-axis. Okay, in this video, today we're going to create a mathematical model from collected data and experiments. It's a short video, but it's a very powerful one because it's something that you're expected to know in this class. So here's some collected data. I got it from a whiteboard from some students. And so what they did was they went ahead and they measured the volume of an object in cubic centimeters and the volume of that object filled with water in milliliters. And then from there, they're able to generate a y equals mx plus b graph. And how they were able to do that is with the Chrome Google Sheets. So over to the left, you'll see the actual equation that was generated, and we've got a best fit line, we call that a trend line, and our equation in the form of y equals mx plus b. And so what we're going to do with this equation is we're going to turn it into a mathematical model from this collected data in the lab. So we've got our y, and we've got our slope of 0.711 for m. Our x is our x variable, and b is our intercept at 1.69. It's where this line intercepts the y-axis. So what we're going to do in this class, we do not measure y or x in this class, but instead we measure variables instead of x and variables instead of y. In this particular experiment, the variable for x was a volume. The units for that variable, in parentheses here, are in centimeters squared. For the y, it was also a variable of volume, but in this case, the units are going to be in milliliters. So to turn this into a mathematical model, all you simply do is you take your y and you put in the y variable that you measured in an experiment with its proper units. So all I've done is I've taken this, my volume in milliliters, and I've copied it right here in place of my y. Now for the slope, it's going to be a little bit more challenging for a lot of students because the slope not only has a number, but it also has units of rise over run. So let's take a look at our graph here. Here's my slope, and I look at the units. These are going to be the units for my rise numbers, and these are the units for my run numbers. Oh, and I do have a typo here. That should be centimeters cubed, not squared. Centimeters cubed. Because here in my mathematical model, I have the correct units here. So these are my rise and these are my runs. For the x variable, I measured the volume in cubic centimeters. So here's my volume, which is my variable. Cubic centimeters are going to be my units. And then finally, my plus b intercept. It's where this line hits the y-axis at 1.69, and the units for my y are going to be in milliliters, which is why I have milliliters here on the end for my b intercept. Okay, so today in this video, we created a mathematical model from collected data in an actual experiment.